Hi, my name is Megan Benavides, and this is Learning is Not Quiet. And we are here today to take our place value understanding to the next level. We have a lot of work to do today, so I'm going to get right started. So, the first question that you have here is 452,904,620,042,826. It shouldn't say and there. That's a problem. But I think we are converting these into word form. And the reason that this gets harder is because now we're in the trillions place. So I'm going to write this number out and I'm going to show you how we chant out to this number. So 452 trillion, 452 trillion, 904 billion, 620 million, 42,000, 826. So this is my full number, and it's actually hard to see because it's so stinking huge, but it works exactly the same, and all numbers follow this pattern because we're in the base 10 system. Again, just like we talked about yesterday, we're going to start counting at our imaginary decimal, which is right next to that ones place. Very difficult not to get the sunshine to glare on here. But we have ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions, trillions, 10 trillions, 100 trillions. So lots of numbers, but when I look at my answer, I read it out in the exact same way. All right, so it's showing me this number, and I think that was actually an incorrect answer it showed there. 452 trillion. Yeah, that answer is totally wrong. It should be the one that is shown on my whiteboard behind me. So if you were doing that one by yourself and are checking, this is the actual answer. Okay, so which digit is in the quadrillions place? So again, I'm going to count from my 6. Ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions, trillions, 10 trillions, 100 trillions. So if I'm looking, and I want to see if I put the answer correct. Yeah. So it's asking for what the digit is in the quadrillions place. And the quadrillions place would actually be to the left of my 4. So since there's nothing there, it's actually a 0. Which digit is in the trillions place? Let's count it together. Ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions, trillions. So in my trillions place, we have a 2. Number 4, which digit is in the 100 billions place? So once you get really good, you can speed this up. So you have thousands, millions, billions. And so I'm looking for the third digit because we're looking for the 100 billions place. So that would be a 9. Which digit is in the 10,000s place? So again, I have my ones, I have my thousands. So in the 10,000s place, the one next to my thousands is a 4. Which digit is in the tens place? Ones, tens. Tens place has a 2. So again, pause. My expectation is that you're doing all of this on loose leaf paper with me. And here is your answer key if you'd like to check. These are the exact same questions that are on your worksheet. So if you're just following along and you're doing this on your loose leaf paper, you're doing a great job. All right, so it says, these are the tricky ones. I'm thinking of a number. If you add that number together, all the digits of this number, it equals 25. The tens place has a digit that is equal to 3. Oh, I see that. Oh, 3 squared, sorry. has a digit that is equal to 3 squared. I see that and I'm already like, boom, I know 3 squared is 9. Because remember, squared means that number times itself. So 3 times 3 is 9. So, no, that's not going to work. I'm going to leave a spot for my ones place. I'm going to add in my 9. So if you see my wonky whiteboard, ones, tens. And this is equal to 3 squared, or 3 times 3. Capiche? Moving back. Whoops, moving forward. The hundreds place is 1/3 of the tens place. So I think if I were to divide this number by 3, if I take 9 and divide it by 3, 3, 6, 9, that is actually 3. So the hundreds place is 1/3 of the tens place. This is a hot mess over here. Probably all of you watching this video are better at YouTube than me. So I have a 3 in my hundreds place. The thousand and 10,000s place feature prime numbers. So thousands and 10,000s place are going to be prime. So remember, a prime number is a number that only has 2 factors, 1 and itself. None of the digits repeat. The 10,000s place is smaller than the thousands place. Wait, let me see if I read that again. None of the digits repeat, and the 10,000s place is smaller than the thousands place. Okay, so again, this is such a long and dense question. I want to make sure I've got everything. I'm thinking of a number. If you add it together, all the digits of this number, it equals 25. The tens place has a digit that is equal to 3 squared, so we've already identified that's 9. The hundreds place is 1/3 of the tens place, which is 3. The ones place is 1/3 of the hundreds place, so I missed that. That's why we need to read it again. So 1/3 of 3 is 1. The thousands and 10,000s place feature prime numbers and none of the digits repeat. The 10,000s place is smaller than the thousands place. Okay, so this is what I have so far. I've just taken the information from the question and written it down on a whiteboard, basically. So we've already gone over these 3 a lot of times. This is 3 squared, this was 1/3 of that one, and this is 1/3 of this one. So we have 391 is for sure whatever these last 3 numbers are gonna be. So my total number needs to equal 25. So I'm gonna see what 9 plus 1 is 10 plus 3 is 13. So 13 plus what equals 25. Now, if you're not the best at mental math, if you're good at mental math, you can do it in your head. If you're not the best, we can just count up. So we have 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So my answer here is 12. So these 2 numbers here have to equal 12. And I'm going to show you right now that that's true. Just double checking my own work too. So we have 13 plus something is 12. So these 2 numbers here need to equal 12. So they have to be prime numbers. So I've already used 1. It could be 2, but then the other number would have to be 10, and that's not going to work. So I'm going to cross that off. Couldn't be 3, already used 3. Can't be 4, 4 is not prime. 5, it could be 5. Ooh, 5 plus 7 is 12. 5 and 7 are both prime. Now, where could these go? This one needs to be smaller than this one, so 5 is smaller than 7. 5 goes here, 7 goes here. So my answer here, if we double check, is 57,391. All right, moving on to the next one. I am thinking of a number. If you add together all the digits of this number, it equals 28. None of my digits repeat. There are no zeros in my number. My number is the largest possible number that could meet these criteria. All right. So no zeros in my number. If you add them all together, it equals 28. So that's something I need to keep in mind. None of the digits repeat, and there are no zeros in my number. My number is the largest possible number that can meet this criteria. So right away when I see this, I know that I want a 9 or an 8 or a big number to be as far to the left as possible, because these positions are worth a lot more than these positions. So I'm going to go 9, 8. 9 plus 8 is 17, so we're there. 7, so 17, 18, 19, 20, 21, 22, 23, 24. Ooh, we're getting really close. So I would probably do something like, and you can play around with it. Again, there's more than one way to get to a correct answer. So I put here, actually, in my number, 7, 6, 5, 4, 3, 2, 1, because by using a 9, I'm not able to get as many digits in my place value. But there certainly are other ways to do this problem. The key thing that you need to notice is that it equals 28. I'm going to go a little bit faster because I'm now realizing I'm running out of time. Write a number that is exactly 400,000 greater than the greatest number that can be formed with the digit 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. No repeats. So, well, it's hard to negotiate the whiteboard and the zooming. So, if I have the number, I need to, again, put my biggest digits to the left, my smallest digits to the right. So I have 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right, let me just make sure. Oh. All right, so no repeats. That's the biggest number I could form because my biggest digits are to the left, my smallest digits are to the right. Now I need a number that's exactly 400,000 greater. So I'm looking at this, and I'm going to add my commas in, and I know that 400,000 would look like this. Key thing when we're adding big numbers is you need to make sure that you work slowly and that you line it up. I always say to my class, line it up, line it up, line it up at the decimal. We don't really have a decimal here, but that first digit is in line. 0 plus 0 is 0, 1 plus 0 is 1, 2 plus 0 is 2, 3 plus 0 is 3, 4 plus 0 is 4, 5 plus 4 is, count it together, 6, 7, 8, 9. 6 plus 0 is 6, 7, 8, and 9. So our final answer is 9,876,943,210, which is what we got up here. Okay, write a number that is exactly 1 million less than 300 trillion. Now you can check this one with a calculator, but I'm just going to show you the answer. Again, the key thing is writing out that number really big and then writing what you're subtracting from it, lining those digits up. Write a number that is exactly 400,000 less than 1,760,000. So again, I'm running out of time, but line up those two numbers, write them out in written form, and do that subtraction. Your answer here, so you can check after you finish your work, is shown. Write a number that is exactly 1 million less than 700 billion. Line those up, and you will get 699,999,000,000, which is 699,999,000,000, all zeros after that. And finally, write a number that is exactly 200,000 less than the largest number that can be formed with the digits 1, 2, 3 repeated twice. So just as, and I have less than a minute to finish up, so here's your answer. But if I have 1, 2, 3 repeated twice, the biggest number that I can form is 3, 2, 1, 3, 2, 1, or 321,321. If I look back at this question, it says it wants 200,000 less than the largest number that could be formed. I need to go minus 200,000. These are great practice of subtraction skills. 1 minus 0 is 1, 2 minus 0 is 2, 3 minus 0 is 3, 1 minus 0 is 1, 2 minus 0 is 2, 3 minus 2 is 1. So our answer, as we've shown here, is 121,321. I always forget to say and, not to say and. Happy solving, and